And since Oregon Mesa is part of Portland State University, I'd like to say our land acknowledgement. We're located in the heart of downtown Portland, Oregon, in Multnomah County. We honor the Indigenous people whose traditional and ancestral homelands we stand on. The Multnomah, Cathlamet, Clackamas, Tumwater, Watslala bands of the Chinook, the Tualatin Kalapaya, and many other Indigenous nations of the Columbia River. It's important to acknowledge the ancestors of this place and to recognize that we are here because of the sacrifices forced upon them. In remembering these communities, we honor their legacy, their lives, and their descendants. Okay, so today we're joined by two engineers from Daimler. Daimler Truck North America is a manufacturer of commercial vehicles headquartered in Portland, Oregon. It's an LLC, that means limited liability company of the German Mercedes-Benz Group. Let's introduce our speakers. We're joined today by Lauren Curtius, who's a CCI engineering team lead, and Jesus Meraz, a senior cab mount engineer. So I'm gonna pass it off to you all to, give a further introduction of yourselves and your presentation.
Awesome, thank you. Let me get my screen shared here. Let me know when you actually see it in presentation mode. How's that?
Yes, we can see.
Perfect. Okay. So hello, everybody. I wish I could see all of you, but hey, this is Zoom. This is how it goes from here on out. Thank you all for joining. Like she said, my name is Lauren Curtis, and I have my coworker Jesus with us as well. And we're here just to talk to you a little bit about Daimler today. So I will start by introducing myself. Just a little bit of my background, not so much work related, but just on a little bit more of a personal note. So I actually have a bachelor's degree in mechanical engineering from Oregon State University. So I am a BEAV. And I recently got my MBA in project management from Concordia University. So really trying to do the well-rounded background. So a little bit of engineering and a little bit of business in there. I actually started working at Daimler in 2017, directly after graduation from Oregon State. I actually did an internship there, but we'll get into that a little bit later. On a personal note, some of my fun photos here. So my husband and I actually got married during COVID. We were one of those crazy couples that continued on with the wedding. So about 8 people there. It was a much more fun, small event. This is the puppy that we got. Her name is Riley. We got her during COVID because we were both working from home. Why not get a dog? Outside of work, we do a lot of backpacking and camping and a lot of hiking, as you can see here. So try to be as outside as much as possible because staring at a screen for too many hours a day just gets a little exhausting. One thing that I really like to touch on from a work aspect when doing talks like this is just how I got to the point I'm at now. I think it's really important to share career paths and let people know, especially in middle school and high school age, it seems like really far away to start working. But there's a whole career path that you go through to get to that point, and it's a long journey that I think everyone's is a little different. So I think it's fun to touch on. So how I actually landed this job at Daimler, I was at Oregon State, getting my engineering degree, was at a networking event. I believe it was my junior year. So very started junior year, hadn't really had any internships yet or any job opportunities, and was just trying to get myself involved in the workforce, try to see where I wanted to go that summer. And I actually met my chief of engineering at that time at a networking event. I started as my internship in the summer of 2016. It was a design engineering internship that I just really fell in love with the company and what I was doing. And during my time there, I really tried to be as involved as possible, not just with networking, but getting on as many design projects as possible and really throwing myself into the experience just to make sure that I liked the company that I was at. After my internship, I had decided I loved that company. I loved the work culture. I loved the area that I was in. I loved the work that I was doing. And so I really tried to keep in contact with the people that I had worked with for those 6 months or so after my internship. I think this is something that really everyone should do after doing an internship. It's just a great way to stay connected to the company that you're hoping to work for one day. So in February of 2017, I was actually offered a full-time position to start that October after graduation, which I felt very fortunate and lucky to have that opportunity. It kind of took some pressure off my senior year in college. And now working at the company that I do and being in the department that I'm in, it's still a lot of active networking. Once you get to the job that you or get to the company you're really passionate about, it doesn't just stop there. Your networking doesn't just stop. You don't just say, okay, I'm here, I'm where I'm at, this is it. I really want to just continue growing and continue getting to know as many people as I can. So I've joined quite a few small groups, very similar to what you see in high schools and college. Jesus and I are both members of STEM, which is a club that we both help run. And so it's just a great way to stay involved. So a little bit about what I do. I started as a design engineer, and I was a design engineer for about 3 years with Daimler before I went back to school and decided I just didn't know if design was what I wanted to do for the rest of my career. I really enjoy engineering and I really enjoy the technical side of things, but I also wanted to get a different idea of what the rest of the company did, just a broader aspect. And so that's why I actually went back to school for project management. So again, to just get a little bit more of a well-rounded background. I got that degree and just realized I really wanted to start using it at the company. I wanted to stay within engineering, but do a little bit more of the business background side of things. So project management, I don't know how much all of you have really gotten experience in it so far in your classes or in clubs that you're in, but the expression that people use a lot is it's a lot like herding cats. It is a lot of babysitting, a lot of moving pieces, a lot of making sure other people are doing what they need to. But there's actually a really technical side to it as well. And a lot of project management has to do with budgets and timelines and meetings and really making sure that projects are on track the way they should be. So I've really enjoyed this new career path, if you will. And kind of like I show here, somewhat as a joke, but somewhat serious as well. This is just something that I like to show. Up in the top right corner there is one of my just random weekly schedules of meetings. So I'm in meetings a lot. I think that would concern or worry some people. They might be a little hesitant to it. I personally enjoy it because I like being in the know of all the projects that I'm involved in. I really like talking to people. And so I thoroughly enjoy a schedule like this. And in the bottom right is actually one of my timelines that I work on. So a lot of my job is timelines, making sure that projects are on track, that they're really following the guidelines that we give engineers. So one of the biggest parts of my job is meeting with an engineer that's working on this specific project, and going through their project timeline and making sure, was their design done on time? Was it done within the budget that they were given? Were all of the cross-functional parties involved in this project actually aware of what's going on? And were they given time to do what they needed to do for part of this project? So it's a lot of conversations, a lot of organizational skills that are needed. I'd like to think I'm very organized, so I think this is the perfect position for me right now. And it's a new role that I've moved into where I now have 6 people working for me as well. So it's a very new opportunity to really get to see the people management side of things as well. I'm not just running projects, but I'm actually getting to manage people and see how I want to run a team. So lots of soft skills that you don't necessarily learn in school, but it just takes practice and you learn as you go. And then the bottom left photo is just kind of a fun, these are the latest trucks that we actually have just gone into production. And so Jesus might be able to talk a little bit more about those. He's been more involved in the design aspect of them, but it's just a project that had been going on within our company for probably the last 4 or 5 years, and it just hit production. So It's very exciting, and it's a project that I take a lot of pride in, and I think our company does as a whole. Let me move on to Jesus.
All right. Thank you. Hopefully you can hear me okay.
Yep.
Awesome. A little bit of technical difficulties there at the beginning, so sorry about that. And then a note on that truck that you just saw that Lauren mentioned. We started the first talks about it like 7 years ago. And then finally last year, the year before that, we launched them. So yeah, pretty cool trucks, pretty cool product. Again, I'm also very proud of that one. And we can get a little more into that in a little bit. So a little bit about myself. My name is Jesus Meraz. Bachelor's and master's as well, but both in mechanical engineering, as opposed to Lauren, who got her master's in project management or the business side of things. I started working for Daimler in 2016, and I'll give you a little bit of a story how I got there in a bit. But personally, I've always liked cars. My dad used to, swap engines in the driveway when I was little, and I'd help him hand him tools. So it's something that's still, a big part of my life. Last summer and the summer before that, my brother and I built that engine you see there, took everything apart, took it to the machine shop, and then put it all back together. Together. My brother is 15 years younger than me, so that was a pretty cool thing to do with him. He's probably the age of some of you on the call right now. And then my wife, Yesenia, on the bottom right there, and our dog, Ruby. And my wife also likes cars, but she likes off-roading. And so you can see the Jeep there on the left. So we got married in 2016. And then shortly after, like 2 weeks after, we bought this Jeep. But it didn't look like it looks there. It was actually wrecked. So we bought a wrecked Jeep, and we changed the suspension up and a bunch of other parts that were bent or broken, welded some things up, reinforced some things that were a little weak. And then that's what we have now. And then top right, skydiving. That was my 30th birthday gift from my wife, Yesenia. And if you all haven't done it, I recommend it at some point. It was super fun. Yeah, so that's my, right when we got out of the plane at 14,000 feet, super awesome feeling. And then in the middle there is our daughter. So she was born last year in August. And our life has been a little different since. Not as much time for engines and off-roading, but it's been pretty awesome. So that's me.
Oh, technical difficulty. Hold on. There we go.
All right. Okay, so how I got to this job. So I went to school here in Clackamas, and then went straight to Oregon State University for both my degrees, right? And so in my third and fourth year of undergrad, when I was getting my bachelor's, I was part of a MECOP program, which you get 2 6-month internships the last 2 years of college. So you get a full year of experience. So I applied for that in my sophomore year and got accepted. And so my first internship was actually up in Everett, Washington at Boeing, working on airplanes. And then my second internship in 2012 was here at Daimler Trucks. And that year I was in chassis engineering in the suspension group, a group that Lauren also ended up working with in eventually. And one of my main project that summer was this continuous cost improvement, which is what Lauren is involved in. And so I had this project. We converted a part from a weldment. It's on the left here. I don't know if you can see that. And that's just basically a lot of parts that were welded together to make one part. And so we decided we could save some money if we just made it one piece and made it out of just one single poured molten metal into a mold, and then it would be cheaper. And so it ended up saving $97,500 a year. I did the math back then, and with that savings, I paid for like 22 interns' wages. So that was pretty cool to be able to say at the end of my internship, and that's per year. And then during the internship, I made sure to join groups at work. And that year, we launched the Latino Employee Active Partnership Group, and I was there for the kickoff. I was the founder of that. and still have my shirt from 2012 that I wear occasionally. So that's been pretty cool. And then after that, kind of like Lauren mentioned earlier too, I kept in contact with my manager from that internship, kept in contact with my mentor. My mentor also happens to be a gearhead and like cars, is building a 51 Chevy truck from the ground up. And so we would email back and forth while I was in school. I would get updates from him, things like that. And then in 2013, I applied for another internship at Daimler. Wanted to make sure I kept the connection, wanted to make sure I kept my network and made it even bigger. And so I was actually in a different department, worked in mechatronics engineering in the brakes group. And main project there was working on a manufacturing tool for brake line cutting, but was able to reconnect with my network from 2012 and then continue to grow it within the new department. And then I went back to school, to grad school for my master's, and had an internship at HP actually during my master's. And that's how I got a full-time job at HP in Vancouver. And you can see that printer there on the screen. Printers are one of those things you really don't think about much, right? You just hit the button, it prints paper sometimes. And until you work on them and you see what everything that's in there, a lot of times you'll hear a printer, when you start it up, it makes all these noises, but it's not really printing anything. Well, that means it's getting ready and it's like cleaning the nozzles and stuff like that to make sure that your picture is going to look good or your text is going to look good. Well, I was in the group responsible for making sure that the ink was going to come out correctly. And on that printer you see there. And then from there, about a year later, I came back to chassis, back to the suspension group, which was my goal. And that's when I started working on the 49X that you see there. And just a little bit about these trucks. 49X is basically a revamp of our legacy trucks. And these trucks are made to do really heavy duty work. So you can see that's carrying, that whole truck probably weighs, 100,000 pounds with all those logs on it. And it's made to carry these logs on gravel roads, off-road, like really severe stuff out in Canada and like in mines, things like that. So that's basically what this truck was made to do. And I'll explain a little more how we know that it can do that in the following slides. But yeah, that's kind of how I got to where I am.
I will say a few comments on this one too. One, I think it's hilarious that we both use that photo of that building. For background for everyone, that beautiful new building that was built about the year that we both started at Daimler. Yeah. Neither of us actually work in that building. That is the really fancy HQ. It's the headquarters we bring all of our customers and our suppliers to. You can't see in the photo, but Jesus and I both work at the very small building right behind it. But this is a fun building. We eat lunch in this building. It's a much more Google meets IKEA kind of building is how I describe it.
Perfect.
Yes. And one other thing just kind of cool about this 49X, I think a lot of people think of, say, Toyota or Honda, and they think a new model of, one of those vehicles comes out every year. You get a Corolla and there is a new model every single year that comes out of the Corolla. When you look at these semi trucks that Jesus and I work on, they're updated maybe every 10 to 20 years. So that's why these trucks are such a prideful thing for us, something that we've been working on for so long, because a new version of this hasn't come out, well, at least for the 4900, Jesus, like 25 years or something crazy like that.
Yeah.
So it's a lot of updating that goes into it and a lot of engineering and design hours that go into these updates. So it's very exciting. And we'll get into that a little bit more, all the work that goes behind that. Let's see if I can get this to work. Perfect. Okay, so I'll speak on this one just a little bit first before Jesus takes over. So really the two of us and our groups work really well together when you look at a design engineer and a project manager. So this is kind of the entire process that goes into, say, an old truck model that we're going to be completely redesigning or updating. So when you look at the defining customer requirements or the project scope, that's really something that my team works on. We're also looking at these project estimates and how many hours are really going to go into something like this? How much money do we think our company is going to spend just in this project work alone? And so my department and my team does a lot of that upfront work for projects where we're planning ahead. And then we kind of hand it off to the design engineers like Jesus to say, hey, this is how much time you have. This is how much money you can spend. Take it from here and design us a new process. Let me go one more. There you go, Jesus.
Yeah, so that's a perfect kind of introduction of they look at all of those things and they come to us and say, hey, this is what you got to do, and this is when you got to get it done by, and this is the amount of money you have per part. Now go. And so we can't just look at a part and say, okay, we're going to make this like the best, most awesome part you've ever seen in your life, because that's probably too expensive. So we have to kind of dial it back and not, we can't just put all of our dreams down on paper. And so we got to really think about what are the requirements for the part? What does this part really need to do? And then once we have a good idea of that, then we could go out and start making some concepts, start bringing up some ideas. And they don't have to be perfect. You don't have to think about everything. You just kind of put your ideas on paper, draw things on the whiteboard, really rough sketches, things like that. And then we can really start looking at, once we have that, then start seeing, okay, how is each of these ideas going to fit into what this part really needs to do? And once we look at, does it fit in the space? Is it made of the right materials? Is it strong enough? Things like that. Then we can choose a concept that's the best. And usually we do that as a team, right? We look at a concept and as a team, making sure that everybody is giving their input and everybody's giving their thoughts. And then we go into a detailed concept, which means that then we can really start putting time and effort into making this part something that we can actually produce and put on a lot of trucks. And then we go into some analysis or validation. And I'll go a little bit more into that here in the next slides. That's a general overview.
There we go.
Cool. And so concept creation. Did you want to cover this one, Lauren? Do you want me to do it?
I can do this one.
Okay.
This is it might age Jesus and I a little bit for you guys. I'm not sure the age group here. But this is always something that I think is really funny because I tell people I'm an engineer for an automotive company, and this is what people first think of. They remember those hamster commercials or Matthew McConaughey talking about the Lincoln that he drives, and they really have just those ideas of like, oh, this is what engineers do. It's just a concept and it's just a fun commercial. But there's so much more that goes into it than just the pretty colors and, really looking at more of a drawing. It's a lot more work and, like Jesus said, teamwork that goes into each of these. So what we really look at, and I'll let Jesus take over after this one, but what we really look at is a lot more of drawings. We have a lot of people in our art department that I think people don't really think of when they think engineering. I think they think a lot of math, a lot of computers, which is true. We have a lot of both of those. But we also work with people in the art department who are either doing hand drawings like this, much more concept, like big picture focused. We also have a clay department, really cool group, that they actually are making models of what we're going to make life size, but on a scale like this big, and just clay models to do really basic, say, wind tunnel testing. Before we put a whole truck into the wind tunnel, we're going to do really small scale down models, basically just from clay. And so it's really interesting to see that marketing is involved, that we bring artists into it, and that it's much more of a brainstorming situation. It's never just one person making decisions in an engineering department. I work on a team of 6 to 8 people usually. I think Jesus is about the same right now. None of these decisions are ever made on your own. So it's really cool to be able to do these as a team.
Yeah, totally.
There we go.
Yeah, and so now the testing, how we make sure that all of our designs are going to live. So there's a few ways we can do that. The first thing we do, and so like Lauren said, a lot of computers, right? And so all of these parts are designed on a computer in 3D. We use a program called the Next, but there's lots of them, like Google Sketch is one that's very similar. You could go out there and use yourself. And so basically just like that, and then we can run an analysis within the computer and tell the computer, hey, this is what this part is made of. this is how much force, how much weight, this is, whatever that part happens to need to do, this is what's going to happen. And then we let the computer run all the calculations, go through all the math, and tell us how close that part is going to be to failing, depending on the material that we use. And so the colors you're seeing here indicate stress level. And depending on the material, we know what stress is acceptable. And so we know, this part is going to be most likely going to be okay, or this part looks like it needs some work. So then we go back and make some changes and run it all over again.
And there are plenty of times where it has a lot of changes that need to be made. It's never I drew something, it's going to be great, and then you move forward. There are lots of variations that go into our designs.
Yeah, for sure. And one of the great things about doing it in the computer is that before computers, you would, use the math you learned in school, go through and do some hand calculations really quickly and say, okay, I think this is going to be okay. And then you make a part, and then you test it in real life, and then maybe it fails, right? So then you just made that part, you spent the time, you spent the money, and now it didn't work. So you got to go all the way back again and do it over. So this way, when you do it on the computer, it's quick. You don't have to actually go break any parts, and you don't have to spend the money. You just put it there, put it together, and let it run. And so not only do we do individual parts like that frame rail, the green one on the left, but we can put things together like on the right there. And we can see how all the parts act together as a unit. So eventually what we do is build an actual truck and then drive it over a track that just beats the truck up. And like, it's very violent. I've ridden on it, and I don't know if you guys know, but truck seats move up and down. They have a suspension on them. And when you're going over the track, and you're in one of those seats, you're just like going up and down really high. I've seen somebody hit their head on accident on the top of the cab. Oh, there we go. Lauren did it. It's a lot of motion. And so one of the things we can do is we can actually run the truck over that track on the computer too. So that's what we were seeing on the previous slide. And then the other thing about all these designs, right? Lauren mentioned that like things have to look good. You get marketing involved, you get artists involved, but on top of looking good, you actually also want to make sure that there isn't too much drag, right? So I don't know if you've seen, Tesla commercials, Mercedes-Benz new electric vehicle, and Lucid Air, all of these new electric cars, and they're all super, sleek, and they just cut through the air very easily. And our trucks also are very sleek. Even though they're really big, they're very, very aerodynamic. And that's because the more aerodynamic you are, the less power it takes to push this big truck through the air. And the less power it takes, the less fuel you have to use. And so if you can use less fuel to move this, whatever you happen to be in their diapers, whatever car goes in this truck, you can tell I have a baby, then you can be more fuel efficient and save a bunch of money and put less emissions out into the environment. And so that's kind of a thing we work on a lot. And so we can look at aerodynamics in the computer, like is on the bottom right there. You saw the video going, and it shows us, what the air does, how much power it's going to take to push this vehicle at certain speeds, things like that. But then we also want to make sure that what we're putting in the computer, remember, all of these analyses are big, fancy calculators, right? And you could technically do all this by hand, which is probably going to take you years to do all the math, right? And so with a calculator, you all know that you put garbage into a calculator and you get garbage out. So when we run these analysis, we also want to make sure that what we put in there was actually what happens. And so in 2004, Daimler built a wind tunnel so that we could put a full truck into this wind tunnel, turn on these big 10 fans and make winds up to 65 miles an hour go over it, and then measure how much force it takes for that truck to cut through that air. That cost $3 million. It's a pretty cool thing to see. We have rain simulators as well. So you can see
the
what
rain is
does.
pretty cool. The rain, they actually dye it a different color as well, depending on the test they're doing. So you can really see the leaks that are happening or the lack of leaks usually. And you think a wind tunnel is going to be super climatic, and then it's not, because you obviously can't see the wind. All you see is little bits of the truck shaking every once in a while. But it's really cool to see how fast these fans are moving. And I've seen people try to stand in the wind tunnel while it's going. That's never a good idea. But it's really fun to watch these tests and see all of our hard work and all of our designs really be put to the test. It's really cool to be able to witness.
Yeah, and then one other thing with this, and something that I really hadn't thought about, one thing that's cool about the rain is that if you're ever in your car, right, and it's raining, which it does around here, you can look at where the water goes, right? Look at the water hit the windshield and then how it goes up, or it goes around the sides and then it goes down the windows. And sometimes the water just like stays in a spot and spins. All of these things are super important, because if that water goes and it's, like sticks in one spot where it blocks your view, we don't want that. So we can see that happening here in real life, and then make changes to the design to make sure that doesn't happen.
Sweet. Okay, well, I know we ran through a ton of information. We really just wanted to spend and leave as much time for questions as possible. So I don't know. I think we have the Q&A open.
Yep.
Let's see.
Yes, we do have the Q&A open, and let me just remind everyone how the Q&A works. So if you click on the Q&A button at the bottom of your screen, you could submit questions. I see one of you has already submitted some questions, and everyone else, you can upvote. So if there's a question that you want to see answered first, you should click the thumbs up button next to that question. I will ask one of my questions first, just to give you all some time to submit to the Q&A. What is the biggest challenge in your work right now?
Jesus, do you want to go first? Do you want me to take that one?
Go ahead and take that one first.
Okay, the biggest challenge in my work right now. So the group that I am in now in project management is specifically called Continuous Cost Improvement. And so it's a group that's very innovative. We're taking designs from previous truck models and trying to find ways that we can make them more efficiently, more cost effective, and really save the company money overall. The biggest challenge that I think we're hitting right now is the fact that there are so many other projects going on. People in Jesus's department have hundreds of other projects, that it's really tough for people to prioritize. I think that is a really strong lesson to learn. And I think a lot of you are probably seeing this in school right now and in homework as well. You have so many different deadlines that having to learn to prioritize different projects and different deliverables. That's been really tricky for me lately, just because our workload's so high, but I think it's a learning opportunity, and I think it's much more of a team discussion. It's something that I'm continuously working through with the 6 engineers that work for me, and trying to make those decisions together rather than deciding on my own what's the most important to be working on.
Cool. Do you want to hear mine as well?
Yeah, you too, Jesus.
Yeah, so one thing we mentioned, right, is that we work together, right? You're never working alone, you're never making decisions alone. And so we've got some projects coming here for the future. We're working on electric vehicles. So we're making electric semi-trucks, which is pretty exciting. And we get to make these semi-trucks, not just here in Portland. We don't design them here by ourselves. We actually work with partners globally. So we're working with people in Germany, we're working with people in Turkey, we're working with people in India, all over the world. And so we can work together to make, the best product. And that also means that we need everybody to kind of agree on the best solution. So it's difficult sometimes to make sure that, what is best for us here, that we try to get that to go into production or get that to be the best decision, when maybe somebody in Germany has a completely different vehicle, and they're like, well, maybe we want to tweak this a little bit. So there's always compromises. There's always us, working together to make sure that everybody's needs are met, and doing it in the most efficient way possible. So one of the biggest challenges is just getting alignment kind of globally, and making sure that everybody's on the same page and that everybody agrees with what you're doing. And that's one of the great things about working together, right? There's always somebody to check your work. There's always somebody to give you their perspective. Maybe you didn't think of something that they did. And then that saves you from making the decision that wouldn't have worked. So.
Okay. Thank you all for answering. Our next question is, did you both know what you wanted to do when you were in high school or college?
Oh, I think that Jesus, I won't speak for him, but I knew that I wanted to be an engineer since I was in elementary school, probably. I loved cars all growing up. I loved, very stereotypical, but I loved Legos. I loved taking everything apart in my parents' house just to see how it worked. And half the time I couldn't put it back together, but that was okay. I figured it out. So I knew really early on that I wanted to be in engineering. But I think my career path changed a lot from what I originally thought I wanted to do. And I think that's okay. I think a lot of people think that they have to go into college or go into their career knowing exactly what they're going to do. And I just think that puts a lot of pressure on people. And I don't think that's necessary. I have changed my complete career path just since I started at Daimler over the last 5 years. And I'm very thankful for where I am now. And I think I knew I wanted to be in engineering, but I had no idea what I wanted to do with it. So I think it's really fun to keep an open mind in that. And there's lots of courses that you can take in high school and in the beginning of college that are really career based, and you get to see a little bit of a bunch of different industries and learn what interests you the most. So even though I knew I wanted to be in engineering, I still took advantage of courses like that to make sure that I had made the right decision.
What about you, Jesus?
So I similar to Lauren in that I also like cars, right? My dad worked on cars and did engine swaps, and I helped him, and that was something that I always liked, and I found very fascinating. And the difference, though, with me is that I didn't know what engineering was. I didn't know it was a thing. So it really wasn't until I got to high school that I really started to think about, well, I can do math. Okay, I wasn't the best at math, honestly. I like science. I like working on cars. And that's when I started thinking, well, math and science, that's kind of leading me to engineering after, I asked or went to a career fair. And then originally I was thinking structural engineering or civil engineering, something like that. And it wasn't until actually I met my now wife, who had a mentor who told her about mechanical engineering. And then she introduced me to mechanical engineering. And I was like, wait, so all these engineers that design these really cool cars, like you can do that with a mechanical engineering degree, like sign me up, right? And so that was kind of the dream, right? Let's work on some cars, let's design some cars. Now we're working on trucks. I worked on printers for a little while. So you can see it's not exactly the same thing, but really, if you look at a truck, a lot of the concepts are the same as a car. The difference is that trucks are meant to pull really heavy loads and transfer really critical things all over the world. And so you can really make an impact designing trucks. But that's when I realized that engineering was for me. And then I started college, and the first 2 years of college is really introductory courses where they kind of show you general engineering, not specific mechanical engineering or automotive or nothing like that. It's just general courses. And so that's where I really got a feel for what I did and didn't like. And at any point during those first 2 years, I could have changed from mechanical to, civil to industrial. Like I could have changed my career path at that point too, if I found out, maybe designing cars or, doing this mechanical engineering thing isn't for me. So I liked it, and here I am.
Yeah. It's glad to hear that both of you had very interesting stories. Like you kind of had an idea what you wanted to do, but the way of getting there was a little bit not necessarily traditional, but that's good. It shows that like you can change your mind, you can always learn more. That's really positive to see. Our
It
next
also
question.
helped.
Go
Oh,
ahead.
sorry. One more thing. I was just going to say, it also helped that we both went to Oregon State. There are, I think now 14 or 15 different engineering majors at Oregon State as well. So there's plenty of different options and opportunities. I learned tons about chemical and biomedical engineering as well. So even though we both ended up in mechanical, there's so many different options across engineering.
Yeah. Even within mechanical engineering, you can specialize in different areas, right?
Mhm.
You know, there's combustion, there's material science, there's
Both of our
so
spouses are mechanical engineers and are in completely different industries than we are. So it's pretty
yeah,
cool how vast it is.
yes, yes. All right, our next question is what other skills do you think are important to have when working professionally, not just hard engineering skills?
That is a great question. Um, One thing that I learned during college and being in so many engineering classes that were very focused on the math and the actual engineering skills, was that I wasn't getting a whole lot of practice with presentations or communication or just those very basic conversational skills. And so I actually did a minor in communications, which I think a lot of people that I was going to school with just thought was hilarious because you don't see a ton of engineers who want to openly be having discussions. And I think it's kind of a stereotype that people think that engineers might not be great at communicating with people or whatever. I think that's a very old school stereotype to see. And so doing a minor in communications taught me a lot of soft skills that I now use on a daily basis. Really simple things like learning how to create a PowerPoint or being able to really communicate the design ideas that I had really helped me in my first couple of years because I had a mentor actually tell me if you have a great idea or if you have a great design and you don't know how to present that or communicate it to a group, that design isn't going to go anywhere. And that really hit home for me. I was told that during an internship, and I went back to school and thought, okay, I really need to learn how to communicate these things because being able to kind of bridge the gap between people who have an engineering background and people who don't is really important in any industry that you're going to be working in because you're never going to be in a room of people that all completely understand what you're talking about, and that's okay. I don't think I have ever been in a meeting room where we're all working on the same project. There's people from tons of different backgrounds with tons of different engineering experience even that differ so much. Being able to have those open conversations has made my job a lot easier and I think a lot more enjoyable too.
Yeah, one of the things that is really important is if you have an idea and you can explain it, right? If you know, so like even in school, if you're working on something and you're learning something new and then you understand it and somebody else doesn't, if you can take that and explain it to that person in a different way and help them understand it, that's like a really good thing to know how to do. Because that like lets you take what you have in your head, you know, that idea, that design, whatever it happens to be, and be able to break it down and say it and present it in a way that others can understand it. I mean, I think that's what Lauren is referring to. So yeah, super important. I will add to that. And this is something that like it's a soft skill, total soft skill, nothing to do with engineering, and that's being able to talk to people. It takes you, networking is super important regardless of what you do, whether you're an engineer or in law or wherever you end up in life. Being able to get to know people, being able to get people's trusts and you know, understanding, and being able to put like a team of people around you that can help you and that you can help kind of achieve each other's goals. That's super important. So even if it's just, you know, meeting somebody and being able to spark a conversation and, you know, see how they're doing, that's going to make a connection that you then later, when you maybe, like if I had just met Lauren and then I had an idea for saving some money on a design, I could then go back to Lauren and say, hey, how are you? How is your dog doing? How is your husband? Right? Talk about those things for a little bit and then pitch my idea to her. And again, break down that idea I have in my head to her in a way that she'll like make sense of it, because I can explain an idea in a very bad way and you wouldn't have any idea what I'm saying. And so if I could do that, then that will kind of really help me and her understand each other and then move forward as a team to get this idea implemented and save the company money.
Yeah, it's very important to talk to people and make connections.
Yeah.
And even for students, talk to your teachers, talk to your professors, ask them how they're doing. When I was in college, one of my engineering professors, um, I'd gone to his office one day for something and his daughter was there. I think he had to pick her up early for some reason. And then every time I saw him after that, I'd always mention his daughter. I was like, oh, how is she doing? And his face lights up. And then he's so much more willing to help me with my homework and my grades. Because people want to feel like important and they want to feel remembered. And I think that's very important, not just in the work that you do, but creating those relationships.
Definitely.
Yeah. Okay. Our next question is, where are the trucks manufactured?
Oh, all over the place. We have one plant actually in Portland, just down the street from where Jesus and I work, which is really cool. Being able to be in the plant and see one of your designs going down the line is awesome. We also have a few plants on the East Coast, mostly in the Carolinas. And then we have 2 plants in Mexico as well. So that's just for our portion. We also have a bus manufacturing plant in the South. And there's there's a Mercedes-Benz plant, I think in Alabama, if I'm correct.
Yep.
So really all over the country and in Mexico.
Yep.
Thank you. Next question is, do you all mentor other people that just started out at Daimler? If so, how?
You want to take this one, Jesus?
Sure. Yeah. So as an intern, I had a mentor, and it was really helpful to have somebody to ask questions to kind of help guide me through the company. It's a completely new environment, right? Corporate world. And so one thing that I've tried to do every opportunity I've had, first is have interns when I can, right? So I was an intern once and I had a mentor, and then I was able to be the mentor for other interns. And so that was super awesome, is to bring somebody on board, kind of show them how things work at the company, and then kind of watch them kind of develop into a basically engineer, like a full-time engineer, like performing work at the level of, graduated engineer would perform. The other thing is when new hires come in, right? You don't know the company. And so being able to connect with them and show them kind of how things work, even if just giving them like a list of tips. One thing that I like to do that's very like simple is share my list of favorites. It's kind of because there's a lot of links that we go to, a lot of systems, and I have this just like a list of all of these systems that I can easily access. And so whenever I have a mentor or a new engineer that's going to work with me, I share it with them, and then they come to me with a question: where do I find this? And I'm like, it's your third favorite. And then they have all the information. But anyway, building relationships with them, helping answer any questions they might have, and then just continuing that relationship throughout the years is how I do it.
And I would just point out too, when I first started at the company, I was on a team outside of the department Jesus was in, completely different engineering department. But we had actually met through other coworkers, and Jesus had gotten a promotion to a new job and a new team. And he had actually shoulder tapped me and said, hey, my old position is opening. You should apply for it. And it's that networking and that mentorship really across the company that opens up so many opportunities for you. I actually backfilled his old position, joined his old team. And it was a great opportunity that I don't think I would have thought for myself or really applied myself for if Jesus hadn't said, hey, I think this would be a really good opportunity for you. So even small situations like that I would consider mentorship as well.
Thank you. And that kind of leads into our next question, which is about your internships. Each of you did internships with Daimler, and what advice do you have for making the most of your internship?
Oh, I would say meeting as many people as possible. I know we've said the word networking at least 15 times during this, but that's how important it is. During an internship, I really like to think of it as a 3 or 6 month interview. You're really interviewing the company and they're interviewing you at the same time. I remember really throwing myself into the company culture when I was there. I easily could have just, done the work during the day and then left. but I really tried to understand the company culture. I really wanted to understand what people did outside of work at this company. I wanted to understand a little bit more of the business side of things, of how do people spend their time at work? What projects are they working on? And so I tried to meet as many people as I could from different departments just to get a better understanding of how the company worked as a whole. Um, and I think Jesus and I both touched on really keeping in contact with those people after the internship, because the internship itself is really important, but then you go back to school and you want to make sure that there's not that disconnect when you're finishing your degree. And so I think it was really important to keep in contact with the people I had worked with, kind of following up and just seeing, hey, where did my project end up once I left? How did that design end up? I'm really purely out of curiosity, want to know if it went well. And being able to kind of continue those conversations really keeps your name in the back of people's minds for when you're applying for jobs.
So yeah, that's a very important one. Meeting as many people as possible, and also asking, the question, any question you have. So one of the really important things is when you're an intern, you got like, not that when you're full-time there you don't, but as an intern, people will go out of their way to kind of help you and guide you along. So that's where I really met a few people that are mentors to me now. And so you can really kind of meet people, get to know them, and then, continue that relationship, and then use that as a mentorship for yourself later on. So I met, people that are directors and chiefs. And one of the things that I want to kind of tell everybody is, when you think about, going into a big company or an internship, there's different people at different levels, right? There's managers, and then the people below the managers, and then there's people above that manager. And some places can have, 5, 6 levels all the way up to the CEO. And one thing that took me a really long time to realize, well, maybe not too long, but it took me like a year or so to realize, is that all the people that are at the top, right? That CEO, that person that basically is like in charge of the company, that's also just a person, right? Just like you and I, right? They get up every day and they put their pants on one leg at a time, just like you and I. And when you go up to them, they'll talk to you just like anybody else. So really, it shouldn't be, intimidating to go to talk to somebody that's higher up in the company. On the contrary, you should be looking forward to it, because they have so much experience. You can ask them how they got there, what they did. If that's something you're interested in, go out there and ask the questions. How did you get here? This is something I maybe want to do in the future. And they usually will be very willing to share their story and help you.
And excited to share their story.
Oh, yeah.
People with that much experience want to help the people that are just starting out, for sure.
Yeah.
Thank you for those answers. So we have a couple questions for each of you individually. So for Lauren, when you start a project, how do you decide timelines, and what do you do if things fall behind schedule?
Oh, that is a great question. Anytime we start a brand new project, we look back on previous projects. That's the easiest way to look at it, and just see lessons learned. Lessons learned are a big part of my job. We run anywhere from 3 to 4 month projects to projects that last 5 to 6 years. And even though they're all so unique and so different, we try to run them very similarly. And so looking at lessons learned of previous projects, we can see, hey, why were we delayed here? What could we have done differently to make sure we're not delayed again? So there's always going to be hiccups in projects. There's always going to be roadblocks that you hit. If anyone says that a project at a size company like Daimler went without a problem or under budget, they're probably missing something. Most projects, even if they're done on time, there was a deliverable missed somewhere because they had to make up for it somewhere else.
Yeah.
So I think learning to be flexible is really important. Before I started this job, I was not. I was very, I would say, almost too organized. I wanted everything to go very specifically. And in this position, I've learned it's okay to be a little bit more flexible. The plan's going to change, the timeline's going to change. And at least as long as you're following up on the deliverables and making sure that the key items are done, it's a lot of prioritizing and then just figuring it out as you go.
Yeah.
Yeah. And Jesus, you can add to this if you'd like.
Yeah, so Lauren's right. Things don't always go the way you want them to go, right? And I think that's kind of what happens in life in general. And it's always good to be able to, have a backup plan or options to bring things back. But one thing that you do is work with others, right? So if I'm working on a project and we have an issue and it's going to delay the project, well, we can reach out to other people, right? We have a network. And so you can reach out and say, hey, I made this decision, or, I designed this part and it didn't work out. And now we have to go back and make a new design. Like, can you help me out? Whether that would be like, give me your input, or whether that's, there's this other project going on. Can you please take that project while I focus on this one and get it to the finish line, right? So it's really leaning on your network and leaning on your teammates to help you get where you need to be.
Thank you.
Yeah.
This next question, someone did ask a lot earlier. Jesus,
Yeah.
What is a master's degree, and what is the
Yes.
benefit of getting a master's degree?
Yeah. So for those of you that might not know, there's different degrees you can get in college. So you go to high school, you get a high school diploma, and then you can go to college for a 2-year degree. One example of that is like an early childhood development. That's an associate's degree, and so you can get a degree. It's a shorter term, and you can go out and get a job with that. And then there's a bachelor's degree, which is typically a 4-year degree. It took me 5 because of the internships. No set deadline on these, by the way. It's a flexible 2-year, flexible 4-year, and that's a bachelor's degree. And then a master's degree basically means you took the associates is more general. You go to a bachelor's and you focus in more on a certain thing. So in this case, mechanical engineering rather than just general engineering, right? And then when I went and got my master's, I then had to focus on something within mechanical engineering. So for my master's degree, it was mechanics of materials and material science. So that's my master's focus. And basically it means you dive deeper into something within the mechanical engineering realm. I did a project, so I had to build something and make it work and then write a report on it. You could also do a thesis where you're doing research. So you have an idea or a theory about how something works or something that you could do to make something work. And then you go out there, you do the research, you do some testing, and you prove that it does work or doesn't, and write a report, and then you present it and defend it. And then you become a master and you have your master's degree. And then if you still want to continue after that, there is a doctorate degree which just means you dive even deeper, or you got a bigger kind of research project that you're diving into. So, and then benefits, with a master's degree, you can usually work in different areas or move higher up. Certain places require a master's degree to go past a certain level, or certain places require a master's for you to have a certain position. So.
Thank you for that answer. I know that some of our younger students may not know about the different, collegiate degree levels, so it's important for them to know.
Great question.
So I may actually wrap up our question and answer session with one more question, and I've been wanting to end all of our sessions with this. We're in a very we've been in a very interesting time, and especially for the past 2 years. And while things are opening up again, we do have a few like world events happening that may be a little bit scary for some. And what is your advice for students when they're trying to figure out themselves in such an uncertain time? No pressure. I know it's a tough question.
Yeah, no, it definitely can be tough. A lot going on out there. One of the things that, just like in school, if you have people that you can surround yourself with that you can trust, people you can rely on. Lauren and I worked together on the CCI project a little bit, but we've also become, friends. And so when you can surround yourself with people that you can trust and rely on, and talk about things, because really sometimes all you need to do is talk about things, and then or get some of your thoughts out, get your frustrations out, get your your emotions out, and being able to have a group or a couple of people that you can do that with is super helpful. And also, know that if you're having trouble, like, you said find yourself. If you're having trouble with it, like, it's a journey, right? Like, I'm in my 30s. I am a senior design engineer at Daimler Trucks. I'm applying to be a manager. And you might think, oh, once you get to that level, you have everything figured out. Everything's like you're an adult, like it's all, set. Well, it's not like that. I know right now you feel like, oh man, I need to figure all of these things out. But I just want to let you know, I feel the same way, right? Like we still all have to figure everything out. And it just, as you grow, you figure more things out, and then you find out what else you need to figure out. And so you just keep going through it, and keep kind of advancing and growing. So if you ever feel like I don't know everything, it's okay.
Nobody does. I think that's a great point, Jesus. What I would say is you really have to, and I know this is going to sound super cliche, but I mean every word of it. You just really have to be yourself. I, as a woman in engineering, I grew up really thinking, "Oh, maybe I shouldn't be an engineer. There's a lot of boys in my classes. Maybe that's not something for me. Maybe I should be doing something else." And I remember really doubting myself. I was really lucky to go to an engineering high school and was very aware that I was different from the beginning. And I remember going into different classes and thinking, maybe I should do something different. And then something just kept bringing me back to those engineering classes. And I think because I tried changing myself so much and because I was hesitating so much, I easily could have missed out on opportunities because I wasn't really being true to what I wanted to do and what I really knew was meant for me. As soon as I kind of let those, kind of like Jesus's background says, as soon as I let those biases and those stereotypes kind of fall to the wayside, so many opportunities opened up for me that I just hadn't looked at earlier because I didn't think they were for me. And I think being able to share your own experiences with people who aren't like you at all is really okay. A lot of my friends growing up and in high school and college were guys because that was really the only people I was around. And I think that made me really nervous. And then I realized it's okay that all of my friends aren't like me. It's great to have a diverse background and group. Just be able to learn from other people's experiences as well. And I think the more comfortable you are with yourself, the more accepting you can be of other people as well. And I think I've learned that not only in school, but in my career. And just being true to who you are and not trying to change for what other people think you should be is really important.
Yeah, thank you too for those answers, and thank you for being here today. So I am going to wrap it up with a few announcements for our Mesa students and PSU students. This talk concludes our career week. If you missed any of these sessions, we've recorded them and we're going to be putting them up on our YouTube channel. Mesa students, each session you attended will give you one entry into a raffle for a Spiro mini robot, and you'll be contacted either by myself or your regional coordinator about that in the coming week. Let's see. Next slide. We're still recruiting for Invention Bootcamp. So any high schoolers, if you're interested in, doing a free 4-week engineering camp at PSU, it's going to be on campus this summer during the month of July. Please apply. The application links are there, and we'll be sending this out later. If you are a PSU student and you're interested in being a mentor for the camp, you can reach out to me or inventor@pdx.edu. Okay, we're also having Mesa Family Nights. Middle school family nights are March 15th and 17th, and our high school family nights are April 18th and 20th. You'll get a few emails about this as well, but there's the RSVP link in blue. And I just want to say thank you again, everyone, for joining, students and our lovely speakers, Lauren and Jesus. Thank you so much for coming and spending some time talking about your careers, letting us get to know you and a little bit about your families as well. If you have questions, please reach out to us at ormesa@pdx.edu, and you can find all of our resources on everyday.oregonmesa.org. Okay, thank you all for coming.
Thanks, everybody. Have a wonderful evening.
Thanks, everyone. Bye.